Good evening, everyone. Thank you for coming. So this is one of a series of public lectures within the Malta Group of Professional Engineering Institutions that we represent basically the IET, the Institution for Engineering and Technology, the IMT, Institution for Mechanical Engineers, and the IC, Institution of Construction. I'm not so good. And basically, these are UK professional bodies, and there are these public lecture series happening around every 2 weeks or so. And today with us, we have a speaker from one of the projects which I'm also leading, happen to lead, Promise project funded by the European Commission. And we have basically Henny-Catharina from Anhalt University of Applied Science. I'll let you introduce yourself. Basically, I introduced the name. But I'm quite interested in this talk because it combines two fields, nature and technology, let's say. So, and photovoltaic. So I think we look forward.
Thank you very much.
Thank you very much.
Yeah, thank you very much for the introduction and for the possibility to be here today. And I want to first start with a little background regarding where we're coming from. My colleague Sebastian Dittmann and I, we are from the Anhalt University of Applied Sciences. This is in Germany and in Saxony-Anhalt, so quite central in Germany. We have about 7,500 students, and we offer between 33 bachelor degrees and 40 master programs, and currently we also have about 80 PhD students. We have 3 campuses, and we have a strong tradition in sciences, education, and culture, and each of those are represented in the 3 campuses. My colleague Sebastian Dittmann and I, we are from the Apollo research group, and these are our research topics, metrology. We're also looking into reliability and durability, performance and lifetime modeling, and technology demonstration as well. And all of these topics, they are also represented in our education programs, like our master program, which is an international 3-semester program which focuses on PV systems engineering. But now I want to present you some of our work we do in our interdisciplinary projects, where we are combining PV, power plants, and biodiversity measurements. And our motivation is to find answers to how to tackle the double crisis of climate change and biodiversity loss, which are 2 of the major crises future human societies are facing. And besides the climate change, we have been observing a severe decline in global biodiversity and deterioration of ecosystem functions and their services worldwide. And we cannot fully predict what is going to happen once we have reached those tipping points. But when we're speaking of biodiversity, what are we actually talking about? Because everyone is using the word, but what does it actually mean? So it means it's 3 parts. So it's the diversity of species, it's the genetic diversity within the species, and it's the ecosystem diversity and all the interactions in between those 3 levels. Ecosystem services were organized into 4 broad categories by the Millennium Ecosystem Assessment quite some time ago. And ecosystem services provide us with very essential services for our well-being, such as food, medicines, energies, and fibers. And its estimated average world yearly worth is about 33 trillion US dollars. The state of our natural habitats is not very good at the moment, and the reasons and drivers are multiple. Just to mention a few, pollution is a very direct driver. Invasive alien species as well. I've read that also Malta has some species which might become a problem. Overexploitation is, for instance, through overfishing is a very direct driver. Artificial lights might cause confusion during migration of birds, for instance, or insects are also drawn to light and they just might be dying of exhaustion because they just think it's the moon and they keep flying. Climate change is also a very direct driver, which we can see in the shift of species distribution. Like in Central Europe, for example, we see that certain insects are moving further north because it's getting too hot for them further south. But one of the biggest drivers is the change in land use. So we have a severe, or through the change and the intensification in land use practices like the agriculture, we have a lot of loss of landscape structures like hedges, ponds, field margins, and habitats like this. And this again results into a more homogeneous landscape, which, the less diverse a landscape is, the less species it can support. So it is very important to preserve what is still intact, so the natural areas which are still there, and we should focus on protecting those and also restore if we can. And so we already have a very high competition for land through rising population. The consumption and use of resources are rising as well. And when it comes to land use conflicts, renewable energies are also becoming a more important topic. And to mitigate climate change, photovoltaics are considered as a key technology, which has led to the expansion of PV plants all across over Europe, at least mainland, I can speak of, which can intensify these land use conflicts. So we need to integrate biodiversity measurements into the PV systems which are being built. And we have to think of multiple land use concepts, such as agrivoltaic or agri-PV. And this is what we're trying to face in our interdisciplinary project, Biodiv Solar, where we are also doing research on the PV side, but we're also looking into the development and testing of site-adaptive native seed mixtures, from regional production to support species and blossom-rich grasslands. And as a second part of this project, we're also testing the compatibility of vertical bifacial PV modules, crop production, and wildflower strips on arable land. I focus on the "and" because this is our Agri-PV Plus, so we're trying to combine 3 disciplines in this concept. grasslands are very common in PV plants in Germany, at least. And so far, self-greening is currently very typical. This means the PV plants are being built, and whatever seeds are in the ground, it's left to revegetate itself. Or species-poor seed mixtures are being used. And a standard management is mulching these areas. This means the grass or vegetation is cut very low, and the biomass is being left on site. And this is not promoting biodiversity because wildflowers, they like the light. And if you leave a lot of biomass, it's like kind of, what do you call it? They can't breathe. So nevertheless, PV systems offer a great potential to develop species-rich grassland vegetation. They can be used to create corridors within the landscape, or species can also use them as like stepping stones when trying to get to another nature reserve, for instance. And they can be great pollinator habitats. So why am I saying this, or why I'm emphasizing this? Colleagues of ours, they evaluated the success of self-greening in 12 commercial PV plants. And all PV plants show like a very, very, you can't see that. Yeah. All PV plants, no matter the size, they show like a very similar species number. And also, when we're looking at the age of the PV plants, it shows like a negative effect on species numbers. The species composition is mainly characterized by ruderal species, and only 1/3 is our target species, the grandland species. So what we can conclude from this little survey is that we need to actively think about how we can green or vegetate these PV plants. And for that, we can use wild seed mixtures. And on the figures here on the right, you see the zoning kind of a zoning in the PV plants due to the change of conditions caused by the modules. So under the modules, we see a very, okay, this is very slow. We see a very low cover of our target species. And interestingly, the areas in between and next to the panels, they do not differ very much in the species number or in the cover. But grassland species also have very low, and grassland species also have very low species numbers and cover here. Sorry. So one very effective and fast option to promote biodiversity is the establishment of species and blossom-rich grassland, while using native site-adaptive seed mixtures. And for that, we need to plan very, very carefully beforehand. We have to look at the site preparation, and also the management is very, very crucial for the success of the establishment. Törik and his colleagues, they've come up with 3 phases for a habitat restoration, and along these, I will show you like how we approach the vegetation in our PV plants. So first, we are thinking about what do the wild animals need we want to promote and we want to save. Like, what do the wild bees, the butterflies, hoverflies, birds, bats, etc. What do they need? And it's always wild plants because this is the basis of the habitat. And during the last millions of years, there has been a co-evolution between plants and pollinators. So, for example, here we have 2 wild bees we have in Germany, and they are dependent on certain flowers, and they only collect very specifically the pollen from either only this plant or this one. So if those are missing in the landscape, the wild bees can also not survive and their populations are decreasing as well. So with this in the back of our mind, we are working with species-rich wildflower seed mixtures. So species-rich varies between 30 and 50 wild plants. It depends on which area we want to restore. For example, here we wanted to restore a field margin at our campus, and we used 49 target species, which we wanted to bring back into the landscape. And with these species, we can support, for instance, 55 very specialized, the oligolectic wild bees, or 105 polylactic, which means they're more general, they're not that fussy, from about 600 species of wild bees we get in Germany. Or another example, the seed mixture would support 84 butterfly species as well. While thinking of all of this, we also have to think about that in PV plants we do have additional special requirements on the seed mixtures due to technical conditions, like the height the plant should not grow too high, otherwise we have problems with the shading. And we in Germany use certified regional seed mixtures. So this means, or we have been dividing Germany into 22 different regions of origin. This is due, or the background is to conserve the genetic diversity. We do get the same species in the north of Germany and in the south, but the climate and the soil conditions are still very different. So while dividing all these areas, we are trying to also have a higher adaptation to the existing environmental conditions. And just to give you like a picture, botanists, or our colleagues, they are, for instance, walking around in the area number 1 and they are collecting seeds from the wild plants, and then they are bringing them to a farm which is specialized on just growing those wild plants. So this process is very, it's not easy. It takes a lot of time. And wild plants are not like our cultivated plants. They are difficult to grow, so that makes it also wild seed mixtures more expensive than like a sunflower seed, for instance. And we do have 2 kind of certificates in Germany so that you actually can be sure, okay, if I buy wildflower seeds for my backyard or whatever, or your farm, or wherever you want to restore some areas, you can look them up online, and they will guide you to the farmers who distribute these wild seeds. Our colleagues have also recently published a paper about this concept. There are like more steps to consider And I invite you to have a look into that if you're more interested into this topic. So after all this planning, phase 2 is the implementation. We have 8 demonstrators. 6 of these are PV plants, and we have 2 Agri PV Plus plants. And all of these, they also differ in site conditions. Like some of them are more rich and clay soils, and others are more poorer and sandy soils, so that we can actually also combine and see which works and which might not work. And we also have some special sites, like an old mining site, or a clay pit is also not like a normal arable land or fallow land. Yes, these are our demonstrators. So after we have come up with our seed mixtures, we went into the PV plants and prepared the sites. So we actually disturbed the ground very heavily, so it was milled intensively. So we have like a bare ground, because this is the best starting pool position for the wild flower seeds. And then depending on the area, you can either do the seeding by hand, or you can, of course, also use big machinery. It all depends. And then phase 3 is the sustainment. We have a short and a long-term management. Sometimes, if we are seeding in August, there are still some rains and good conditions for vegetation to grow, but you don't always have the case that your target species are actually growing. So you have to look very carefully what is actually happening. And then if you always need experts, of course. And yeah, then you have to adjust. Okay, the vegetation we don't want is coming up now, so we have to go in and cut it with also different machinery. This can vary whatever the size and what you have. Then we're also surveying, of course, the vegetation, and we are testing also different seed mixtures, because as I mentioned earlier, it's quite expensive also. And we are trying more species rich or more species poor mixtures to see are there huge differences or not. And then also with grasses or dominated by herbs or by grasses to see a difference there. And we also record the influence of the different row spaces, because wild plants, they do like the light, and the further the rows are apart, is there an influence or not? So these are all questions we're looking into. What we can see from now is that we can successfully establish species and blossom-rich grasslands in PV plants. However, not all demonstrators have or had suitable site conditions, so we are still adjusting a little, but this is science, this is research. So we have a large inhomogeneity within each demonstrator, so even the soil conditions within the PV plants or the exposure or the water availability, they differ a lot. And we have a strong zonation within the demonstrators as well. But if we use site-adapted seed mixtures, it works, or it can work. So if we always plan ahead and know the sites, and yeah. Then agrivoltaics is also a big topic for us in our research group, and also there has been increased research and interest in this topic. And agrivoltaic presents an economical solution to address both food security and the decarbonization of our energy systems. There are various possibilities already. For example, you can use it in the fruit or vegetable cultivation. Here, project partners of ours have pumpkins. That's or apple trees. In South Germany, there are quite a lot of plants like this already for apple trees. Then there is the possibility to integrate it in vineyards, and also the combination with wind turbines. So, yeah, there are already a lot of possibilities. And as there has been an increase in the research and interest in these dual systems, nevertheless, there has been little attention about the potential to how this system can contribute to biodiversity and the restoration of ecosystem services. So we are looking into a triple use approach, which aims to increase those synergies of agri-PV systems by linking them to measures to promote our local biodiversity. And here we also have different options within the bifacial modules or system. There's always space which is where the machinery can't reach. You don't want the machines to get too close to the modules, so there is always spaces left, and we are looking into to use these areas and combine them with wild flower strips, but also below the trackers you can use this space, or also in the, like this would be an apple trees or fruit PV system, agri PV system. And we have these two demonstration sites. This is at our campus in Bernburg. And here we have the vertical bifacial system, and combined with a 3-year crop rotation. So we know that millet, soybeans, and durum, they work very well in our area because we also have a quite dry, or the rains do not come when the farmers need it or the crops need it. So we do know that these work quite well in our area. And our interdisciplinary approach is to measure the systems for abiotic parameters like wind, soil, and temperature. And our agriculture colleagues, they are looking on the effects on the yield, and also on the pest infestation. And from the biodiversity side, we are looking into the promotion of beneficial insects and other pollinators. And here we have just a few impressions. This is this year in April when we started, finally, after long planning, and we finally started to build the plant. Yeah, we had some very nice wild flowers already in between, but as we wanted to have an agri-PV plus system, we had to destroy them and seed again, because looking into using the space next to the modules. But it's also a nice example for maybe just PV biodiversity systems. And yeah, next year will be very interesting as we will have our first harvest, and we're looking forward to this. The Heidehof is our second demonstrator, which has been built in 2022. And here, yeah, we did the same. First planning, which area are we in, which kind of seeds or flowers do we want to promote. We seeded by hand because it's just a small area. And the year after, we could already see quite a few wild flowers and plants. Additionally, because it's always a discussion, how is it going to look if we build a PV plant here and there? We were coming up together with a colleague that it would be nice to have like a visualization tool. And for this, we have a little video. I hope the sound is loud enough. Yeah, so this is part of our currently in development or being in development open source web-based planning and information platform where we want to include aspects of biodiversity, energy yield, and social acceptance especially. And yeah, we're hoping this is going to be useful for farmers, engineers, local politicians, and decision makers, because when you can see how it's going to integrate in the landscape, it might make things a lot easier. And yeah, as a summary, I want to conclude that solar power systems and biodiversity are compatible. They can be rich habitats and stepping stones or biotopes, but we do need the interdisciplinary approach, and planning is, we need to plan ahead. So it's not just going in and, yeah, we're just going to build some PV plants and biodiversity is coming back from itself. For further information, we're always updating our website on this project. And yeah, I want to thank the Promise Project, of course. And yeah, thank you for your attention. And if you have questions, yeah, you can ask me now or also later. And I invite you to also follow our journey on our LinkedIn channels. And yeah, just as a discussion, like, what about Malta? How can we transfer some of this to these islands? Thank you.
Very much. Questions?
Having breakfast. One particular feature which stands out is the use of PV panels in a vertical plane.
Mm-hmm.
You put them by side, that's okay. Not familiar with that. But what is the preferred orientation when you're trying to achieve? Because you need the sun and the light for the plants, but you need also the light for the PVs. Where do you orient them? I mean, normally here, obviously, we point south. Where do you point?
In this case, it's, correct me if I'm wrong, not north-south, but it's east-west. Yeah, so we are collecting the morning and the evening light, basically.
Do you have any information that how it affects the PV?
I would have to. I'm not the the professional on the PV side. I'm more on the plants. It's fine.
Maybe because then it's not from the engineering. However, so in Germany, in our place, so the optimum tilt angle would be 35 degrees. So that is then you got the optimum over the year. So the highest yield. But what we have already in Germany, so I would say we don't have enough PV, but we have already fitting into the grid. And we have a very high peak in middays, so a lot of generation, which we actually don't need really the energy. So it's more like in the morning and in the evening you have the highest consumption. So and this PV system, since it's vertical, so you have the bifacial models which are looking at the east and west. So and then you generate more in the morning, on the before noon. And then, so they have the highest peak, and then at middays when the sun is in the south, it goes down, and then it goes up again. So you have like a camel shape. So you avoid actually the high peak in the middays. So this is something for the grid more important because then we distribute better the energy. So that is some solution here. So that is east-west orientation. Yes, and then here. So the benefit what we have here is actually the combination of agriculture and PV. So of course you generate less also on the field because you have wider spaces in between. But the benefit comes to do the dual use, or what we have the triple use here. In our case, that the farmers don't lose their fields, so you have the crop production plus the energy. But if we come to Malta, we will more in the south, so the tilt angle would be here the optimum. That's right. 35, but we tend to put it down to about 10. Yeah. Nowadays. Yes. So yeah, but again, so we have a lot of those PV systems, and if you want to distribute this, maybe also that could be a possibility here to shift it more. Excellent.
Complementing this question, my question is, did you compare, you mentioned potatoes, right? Did you compare the yield of potatoes, the ones which were harvested from these sites, to the ones which were harvested in other sites? And what season the potatoes were harvested throughout all the year, or it was only a particular season, for example, summer?
Yeah. So we have not done potatoes, but
That was pictography.
that was. You mean this? The pumpkin?
Oh, from Frahoek.
Ah. Oh, okay. This one. Okay. That is just. This is from the Fraunhofer Ise. It's just to show what.
Sell the idea.
Yeah, it's not. I'm not sure if I was not involved in this calculation, but it's. But we will also in our demonstrators look into that. Our farming colleagues will be looking into that.
Well, it seems that they produce 103% potatoes, so like 3% more.
But because the thing with potatoes is that they are very, very seasonal dependent.
Mm-hmm.
So it would be a nice way for the example.
Yeah, I can look into that and forward it if I find it. Yeah, sure.
Other questions?
You can, in fact, the picture that was there,
Mhm.
I see some vegetation on the left, on the bottom picture there, growing up in front of the panels. So obviously, I assume you're considering what plants and flowers and things to put in those areas so that they
Exactly.
don't require any maintenance by man, yes?
Well, there will. Well, this is not our PV plant. It's like one example of our partner next to Sun. Of course, we are from biodiversity side are looking into this, that we're selecting the wildflowers so they don't grow as high, but there will always be some maintenance necessary, because if we want to promote the blooming, the plants actually like to being cut now and then. So if you just leave it fallow, you don't promote it. This is also like a co-evolution, like our most diverse grassland habitats in Central Europe, they have evolved with the use of the land. So, but not as intensively as it's being done at the moment.
Yeah, this is the catch-22, isn't it? Because real nature is natural and it deals with itself. So now that we intrude, say, with the panels, we got to try and balance the two together. So
Exactly,
it's, I can see it's a very fine balance.
Yeah, and it's not as easy as it might be, because
exactly.
each discipline is so complex
Yes,
itself. Agriculture, PV, and biodiversity, or nature itself.
Nature,
as,
nature. That's it.
So, yeah, these are all things we're trying to look at, or we are looking into, and trying to find
This is
the
a long project.
best solution. Yeah.
You're doing well. You're doing well. Keep it going.
You need to put them in the soil every year, or
No.
It's just a-
Like with these wild, this is also an advantage of the wild seeds.
so
Let me
they
see.
keep growing every year?
Exactly.
With
If
the
this,
same seed.
yeah, so you do it once. Where do I have like
Keeps on growing up.
like this, the implementation process, you do it once, and then if you manage it properly and not too extensively, but depending on where you are and what species you're trying to promote, there needs to be a cut like once or twice a year. But this is all the planning. You have to know where you are, which species you want to promote. Do they fit in this habitat? And what are the soil conditions? Because the species distribution varies, of course, as well. And then you have, we have flower strips. Like this is like a general measurement in the agricultural areas where the farmers get subsidized for. And we have flower strips which are looking fabulous after 10 years with the proper management. Yeah.
You can always get some sheep
Yeah.
or sheep bot.
Or geese or whatever. Yeah, also the combination with animals, of course, is there are quite a lot of of the big PV plants where you have sheep grazing. Yeah.
Okay, thank you very much. So I remind you that we get public lectures every 2 weeks. I think the next one, I'm not sure. 22nd is the next public lecture. I think it's you. No. I would have to bring a birthday cake. Anyways, so basically, you follow the MGPI Facebook. We will put the post on that. And thank you very much for joining tonight. You can also follow Promise Project, and there is also another project which we're leading, Transit, it's called. There are brochures outside. There are also some surveys on Transit project, so you are very welcome to participate, anyone, yeah? Literally. Thank you very much once again, and have a nice evening.
Thank you.
And if your appetite is open now after this presentation, there is still some food remaining.